This lecture video is about problems about distance. And so all of these are word problems. And here are some steps that you can follow when you're doing any kind of a word problem. First, you should read through the whole word problem carefully, and then declare the variable. You need to choose your variable and state what that represents. And almost always, the variable is going to be whatever will answer your question. So the word problem usually towards the end will ask you to find something, and whatever you're being asked to figure out is almost always that's what you're going to want your variable to be. If it's applicable, you should draw a picture or use a table when that's appropriate, and then set up your equation, solve the equation, and then check your solution, or at least check to make sure that your solution is something that's reasonable. So formulas that we have about distance are d equals r times t. R is the speed or rate. And t is time. So the other two variations of that is that r would be the distance divided by time, and time would then be equal to d divided by r. And these two equations you just get from this equation. So to get the equation for r, you would divide both sides by t. To get the equation for t, you would divide both sides by r. So I usually just remember the d equals rt equation, and I remember it by remembering the word dirt. So because if you just pronounce out DRT, then it's pronounced dirt. So that's what I usually use to remember that. I used to always just remember this equation all the time because it's easy for me to remember the speed that I am going when I'm driving is miles per hour. And so I would know that that was miles divided by my time. But whatever you use to remember the equation is fine. So with all of these word problems that involve distance, you're going to want to fill in this table. And so you'll have some object that's traveling and another object that's traveling, and you'll know some information about their distance, rate, and time. And this table just helps you keep your information organized. So also in some of these word problems, there is wind speed or water current. So a lot of the problems are about planes flying and what happens when the wind blows either up against the nose of the plane, or what happens when the wind is blowing against the tail, and also current if you're in water. So if you're going upstream or against the wind, then the speed in still water or air minus the speed of the current. So you have to subtract off the speed of the current because it's pushing you backwards, slowing you down. When you're going downstream or with the wind, then it would be the speed in still water plus the speed of the current or the wind, because the current or the wind, whichever situation you have it, is going to be pushing you along faster. So you would be adding that speed on to your speed in still water or air. So let's take a look at a couple of different problems. In our first problem, we have a cyclist bikes at a constant speed. So that's important that we note that their speed is constant. And they're doing that for 18 miles. On the return trip is a different route, and they travel 23 miles, and it will take 1 hour longer. And we want to find the speed. Okay, so the speed is constant, and that's what we need to figure out. And so that's going to be our variable. And so this is constant. We'll write this over a little bit. So that doesn't change on either of the routes. On the way there, they travel a total of 18 miles. And on the return trip, it was 23 miles. But on both trips, they travel the same speed. And we know a little bit about how long it takes. We know that it's going to take an hour longer when he goes the 23 miles. So r is your speed, but x is really going to be our variable here. And x is equal to time. And we know that it took an hour longer going the 23 miles, that will be x plus 1. So the thing that's constant, there's almost always one of these variables that will be a constant, and that's the one that you want to have these things solved for. So if we think about this first situation, they traveled 18 miles and it took them X amount of time, and so the rate or the speed that they traveled was 18 divided by X. On the 23-mile trip coming back, they traveled 23 miles and it took them X plus 1 time, and so the rate there would be 23 divided by X plus 1. And so these are constants, so we know that the rate of both of these were the same, and so we can set these two fractions equal to each other. 18 over x has to be equal to 23 over x plus 1. And so if we solve this, then we will figure out the time, and then we can use an equation to figure out speed. So we can use one of these two equations for speed to figure out the speed. So when you have two fractions that are equal to each other, you can cross multiply. So that would be 18 times x plus 1 equals 23x. And just remember to put that x plus 1 in parentheses, because then we're going to need to distribute it, and we get 18x plus 18 equals 23x. We want to get the x's on one side and the constant alone, so we're going to subtract 18x from both sides. And 23 minus 18 gives us 5, so we have 5x equals 18, and then to get x we just divide by 5. And 18 divided by 5 gives us 3.6. And so now remember, x is our time, and that was for when we went the 18 miles. So now to figure out r is equal to distance divided by time. And so the distance that we went was 18 miles, and our time was this 3.6. And so now take 18 and divide that by 3.6, and it gives us 5. And so this is speed, so that's miles per hour. And that was the same whether we were going there or coming back. And so the speed of the biker was 5 miles per hour. Okay, so now we're going to look at our next problem. Our next problem involves a boat. A boat can travel 22 miles upstream in the same amount of time it can travel 42 miles downstream. The speed of the current is 5 miles per hour. Find the speed of the boat in still water. So the thing that we need to figure out is the speed of the boat in still water. So x is going to be, speed of boat in still water. And so now let's go back through our word problem. And the thing that's the same this time is the time. So we're going to want to write equations for time. The distance that we traveled when we went upstream was 22 miles. The distance that we traveled when we were going downstream was 42 miles. And the speed of the current is 5 miles per hour. So when we were going upstream, since x is the speed of the our boat in still water, then when we're going upstream, our speed is x minus 5. When we're going downstream, our speed is x plus 5. Okay, so now we can write equations for t. T is equal to distance divided by rate. And so the time it took for us to go upstream was 22, our distance, divided by our rate, which was x minus 5. And then we can also write an equation for time for going downstream. So we went 42 miles, and our speed was x plus 5. So now, just like before, we have two fractions. These are the same, so we can set them equal to each other. So we have 22 divided by x minus 5 equals 42 divided by x plus 5. And to solve this, we would cross multiply, giving us 22 times x plus 5 equals 42 times x minus 5. So now we have this linear equation to solve. We're going to distribute the 22 and the 42. And we get 22x, and then 22 times 5 is 110. So plus 110 equals 42x minus 42 times 5 gives us 210. We want to gather up the x's on the same side, so I'm going to subtract the 22x from both sides. You could subtract the 42x from both sides, but I'm going to keep my x's positive. So I get 110 equals 20x minus 210. And then we're going to add the 210 to both sides. And that gives us 20x equals 320. And the last step is divide both sides by 320. Or by 20, excuse me. And 320 divided by 20 gives us x equals 16. And this was the speed of the boat in still water. So that's miles per hour. And that is our answer. So the speed of the boat in still water is 16 miles per hour. Okay, so I think this is our last one. So now suppose two trains leave Holbrook, Arizona at the same time, and they're traveling in opposite directions. One train travels 10 miles per hour faster than the other. In 3.5 hours, the trains are 322 miles apart. Find the speed of each of the trains. So they're both leaving from the same place. This is Holbrook, and we have one train going off in this direction and another train going off in this direction. And they leave at the same time. And we know that after 3.5 hours, they're 322 miles apart. So their distance is 320 miles apart. So now let's fill in our table with some information now that we have a little diagram of what's going on. So one train is traveling 10 miles per hour faster than the other train. So our speed, one of the speeds is x. And if the speed of this train is x, then the speed of this train will be 10 miles an hour faster, so that would be x plus 10. And we don't know what their distance is. We don't know how far each of them have traveled separately, but we do know that altogether, between the two of them, they've traveled a total of 322 miles. And also, they've spent 3.5 hours traveling, and both of them have done that. Okay. So now we can write an equation for the distance that each of them have traveled. So this train has traveled a total of 3.5x miles, and this train 3.5 times x plus 10, and just remember to keep that x plus 10 in parentheses. So now we do know that if we sum up the distances, then it equals 322. So take the distance of the first train, 3.5x, and add that to the distance of the second train, 3.5 times the quantity x plus 10, and we know that that was equal to 322 miles. So now again we have this linear equation to solve, and I'm going to distribute this 3.5. So we have 3.5x plus another 3.5x plus 3.5 times 10 is 35, and it equals 322. 3.5x plus 3.5x gives us 7x plus 35 equals 322. Now we want to subtract 35 from both sides, and we get 7x is equal to 322 minus 35 gives us 287. And then the last thing we need to do is divide both sides by 7, and we get x is equal to 41. And so x, remember, was the speed of the first train, and so that's miles per hour. And the question was asking us to find the speed of each train. And so if the speed of the slower train was 41 miles per hour, then we have to add 10 to get the speed of the other train, so that would be 51 miles per hour. So the speed of the trains were 41 miles per hour. Oops. And 51 miles per hour. Okay, so that is the end of this lecture. Let me know if you have any questions. Thanks.